In today's lesson, we'll be learning about rate of change and initial value with a focus on table of values. In our first example, Rogers charges $1,000 for the newest iPhone. Their talk text data plan costs $75 per month. We can represent this information with a table of values. Month 0 represents the start of the month. At the start of the month, you'll be purchasing your new iPhone for $1,000. After 1 month, you'll have to pay $75, which means you would have spent a total of $1,075. After 2 months, you'd have paid a total of $1,150. And after 3 months, you would have paid a total of $1,225. Obviously, you can continue this on for as long as you like. At this point, you'll notice a couple of patterns. The month is increasing by 1. Meanwhile, the total cost is increasing by 75. Therefore, the rate of change in this particular situation would be an increase of $75 for every 1 month. Meanwhile, the initial value would be $1,000, since that is the amount of money you pay in month 0. Before we move on, it is important to know that the columns on the left of a table represent your values of x, and your columns on the right in a table represent your values of y. I can now represent this situation with an equation, y equals rate of change multiplied by x plus initial value. We already determined the rate of change to be an increase of $75 for every 1 month. This is the same thing as 75 over 1, which is the same thing as 75 divided by 1, which is the same thing as 75. Therefore, the rate of change can be simplified to just 75. Meanwhile, we determined the initial value to be $1,000, since that's the amount of money you have to pay in month 0, which is the start of the month. Therefore, I can place 1,000 over here as the initial value. Therefore, this situation can be represented with the equation y equals 75x plus 1,000, where y represented the column on the right, which was the total cost, and x represented the column on the left, which was the month. In our second example, a Honda Civic can hold about 47 liters of gas. It uses about 0.07 liters of gas per 1 kilometer. Let's represent this information with a table of values. If you've driven 0 kilometers, you still have a full tank of gas, which is 47 liters. If you drive 1 kilometer, your gas is going to decrease, and it's going to decrease to 46.93. If you drive another kilometer, it again will decrease, and that's going to decrease to 46.86. And again, if you drive another kilometer, it will decrease even further, and that will be 46.79. Obviously, you can continue this for as long as you want, but I'm going to stop here. At this point, you'll notice a couple of patterns. Your distance is increasing by 1. Meanwhile, your gas is decreasing by 0.07. Therefore, my rate of change is a decrease of 0.07 liters of gas for every 1 kilometer driven. Furthermore, my initial value would be 47 liters, since that is the amount of gas I have when I've driven 0 kilometers. It is also important to note that the column on the left represents your values of x, and your columns on the right represent your values of y. I can now represent this situation with an equation, y equals rate of change multiplied by x plus initial value. We already determined our rate of change to be a decrease of 0.07 liters of gas for every 1 kilometer driven. So negative 0.07 over 1 is the same thing as negative 0.07 divided by 1, which is the same thing as negative 0.07. We also determine our initial value to be 47 liters, since that is the amount of gas you have when you've driven 0 kilometers. Therefore, I'm going to place 47 here as my initial value. Therefore, this situation can be represented with the equation y equals negative 0.07x plus 47, where y represents the column on the right, which was gas, and x represents the column on the left, which was distance.